Hello and welcome to lecture 14 of Math 2R03. In today's lecture, what we're going to be doing is looking at the entire chapter 4, which talks about polynomials. So today's lecture is more on the properties of polynomials. We won't be seeing too much about linear algebra or vector spaces, but we will need a lot of these properties when we go into chapter 5 and chapter 8. The other thing that you might notice is a lot of this stuff is you've seen before, it may be in different contexts. We're not going to go into the proofs in too much detail. We're just kind of want to write down and capture the main results about polynomials we'll need for this course. Okay, so as I just said, the goal of today's lecture is to study the properties of polynomials. So these are elements that look like a0 plus a1 times z plus a2z squared and so on, where all the ai's, which are the coefficients, belong to f. And just to kind of give you a sneak peek about why we're interested in this, well, in the last lecture, we talked about what an operator is. And so an operator is just a linear map from a vector space to itself. And because t goes from v to v, we're allowed to take t and raise it to the power of I. And what that means is we can take t and we can compose it with itself I times. So t composed with itself I times. So it just means if it was t cubed, we would take our vector, stick it into t, take that vector, stick it into t again, and take that vector and stick it into t a third time. And what we want to do when we get to chapter 5, specifically section 5b and beyond, what we're going to be doing is we're going to relate the operator a0 times the identity operator plus a1 times the operator t plus a2 times the operator t squared all the way up to am raised to the power of tm. We're going to relate this operator to the polynomial a0 plus a1z up to amz to the m. So somehow information about this operator, so this is a specific type of linear map from the vector space to the vector space. This information about this operator is captured inside of this polynomial. So we'll need to know something about polynomials to say something about the operators. And this is basically all the linear algebra I'm going to talk about in today's lecture, because what we're going to do is focus on this side, getting used to some of the terminology involved with polynomials. And actually, we're going to take even a step further back and just kind of recall quickly some properties of the complex numbers. So recall that they're complex numbers is the set of all numbers of the form a plus bi, right, where, I'll write this here, where I squared is equal to -1. Given a complex number, the real part of z, denoted real z, is the a, and the imaginary part is the coefficient of the I, so this would be the B. Now attached to any complex number is some other information. So the first information is the complex conjugate. So the complex conjugate of a complex number is the complex number that we get by changing the sign of the imaginary part. And the absolute value, which we write it as in terms of absolute value, is a squared plus b squared, and then we take the square root of that number. So this is information attached to a complex number. Just as some quick examples, here's the complex number 2 plus 6i. So the real part of z is 2. The imaginary part of z is 6. The complex conjugate is 2 minus 6i. And then the absolute value, or sometimes called the length of z, is 2 squared plus 6 squared square root. So that's equal to, ran out of space here. This is equal to the square root of 40. And you may actually remember this. We probably talked about it briefly in Math 1B03, or you've seen this in other courses. Here's kind of all the properties, the complex conjugate and the absolute value. Namely that you can take the complex conjugate and then add, you can first take the complex conjugate of two complex numbers and then add them. It's the same thing as first adding the complex numbers and taking the conjugate. So I won't go through all of them. You've seen them all before, but these are just basic properties of conjugate and the absolute value. So we'll pause here and then we'll kind of talk about polynomials in the next part.